Welcome back to the channel. Today we're going to be looking at something called an Abelian group. A group in mathematics is a set which has a few extra rules. An example of a set which forms a group are the integers, all of the negative numbers, negative whole numbers that is, along with 0 and all of the positive whole numbers. A group also has an operation, like an addition or a multiplication, which combines the two elements to form an element in the same set. For example, in the integers, 2 and 3 can be combined using addition to form the element 5, which is also an integer. A group also needs to have an identity element. This is something which does nothing when you use the operation. So for addition, this is 0, because any element of the integers, for example the number 4, plus 0 is still 4. If we were using the multiplication operation, then the identity element would be 1, because anything times 1 is still itself, which is still in the set. The group also needs to contain an inverse element for every element that you have. This is something which brings the element back to the identity element. So for example, if our identity element under addition is 0, and we start with the element 4, we can use the element minus 4 and add them together to make 0. So minus 4 is the inverse element of 4. The other important rule that a group needs to have is associativity. This is basically what you can see on screen, where the order of the brackets doesn't matter. You still get the same outcome. So far, we've just been talking about general groups. But there's one extra thing which makes a group abelian, and that thing is commutativity. Commutativity is all about the order of the operation. So if you do a plus b, it needs to be the same as b plus a. And the same with multiplication. A times b needs to equal b times a. If these conditions aren't satisfied, then you have a non-Abelian group. An example of a group which does not commute is the group which contains these two matrices. If we define A and B to be these two matrices, we can multiply them together in two different orders, A times B and B times A. But because matrix multiplication isn't always commutative, these two are not equal, and therefore a group containing these two elements doesn't qualify as an Abelian group. Thank you for watching. If you found this video helpful, keep an eye out for other upcoming videos about rings, fields, and integral domains, which are closely related to Abelian groups.